So our next presenter is Kathryn Phillips. So Kathryn is currently studying second year of Bachelor of Computing, majoring in computer science. This particular project, which is called Graphing Together, Visualising Curtin's co-authorship network, is being primarily supervised by Karl Huang from the Curtin Open Knowledge Institute and Marcus Whelband from the library, isn't it? Marcus is here, I think. There. Sort of hiding behind Lucy. And has been kindly supported by the Curtin Library, the Robertson Library. HIVE supervision has been provided by Doshi on this particular project. So,
good afternoon, everyone. I'm Kathryn Phillips, as previously stated, and this is Graphing Together, Visualising Curtin's co-authorship network. To give you a bit of background, the Curtin eSpace is an institutional repository, which means it's a large store of data that contains things like journal articles, published papers, and other exported materials that can be documented. Over 75,000 items in the last, I think it goes back to 1971. Yeah, it goes back to that far. But half of those have been released in the last 10 years, which is a wonderful little thing there. And so, as we've seen today, cooperation, co-authorship is a very good thing. As we've seen by all our projects, it can lead to some amazing outcomes and some unique solutions that wouldn't happen otherwise. And also, it produces some very interesting patterns that you can see. But that can be very hard to look at or notice in the raw data, because just piles of data sheets. So my project is to visualize that in an interactive and a broad display way to really highlight what's going on. So the plan was, at the beginning, is to generally filter down the data from eSpace into what's going to be used, combine it with other elements imported in to give some more information, like where they're from, the authors, and other such pieces, who they are in Curtin. Then modify the existing graph tool, which was mentioned earlier, to be able to display and interact with the data that has been very kindly given to us from the library. The tools to do so are things like Jupyter Notebook, which is a scientific documentation system for, if you've got code, it's good for sectioning things out and giving reasons and including things like graphs and tables within itself for processing. And what was done within there to process that data is pandas, which is another scientific tool that is a very fast data processing library for running data through there. To give an example, I once put together a data filtering system and left it to run, came back a couple of hours later, and it was barely a slither through any of it. But through pandas, it was done in 2 minutes. What would have taken 100 and something hours was just already processed. The joining, the glue between the two sections, is SQLite, which, to put it simply, is just bundles the data up into a nice little package and then hand it to the display. That is then, all of that is edited in Visual Studio Code as a nice lightweight little environment to develop it in, and Unity, because, well, in part it works with the glorious displays here down at the HIVE, but it's also, it's a fairly robust editing suite. First of the data cleaning is the manual steps that are involved. Some of the data had to be modified or removed because in the software that gives out the data from eSpace, there isn't an explicit header for, or that is column name, for data that is withdrawn or removed for any reason. That had to be manually go through. Thankfully, there was only about 6 items, but that's something that needed to be manually removed, as well as, I would say, one of my favorite reports that I've seen during this production, multi-messenger observations of a binary neutron star merger. Quite wordy title, but it's a wonderful thing to see. It's made in 2017. Of course, it's astronomical in origin, and it has over 3,000 credited authors. Not everything, it didn't quite work with the export. It just sort of threw its hands up and went, okay, you handle it. I'm not touching this. And that was just it was a very, very fascinating moment to see 3,000 columns along. And to give you a brief preview of how much data that is, it is, well, it's quite a bit. That's still going. I might cut it off just there. We're going to still be here for a while. Is that was a yes. Then, thankfully, it goes into automatic data cleaning, which is just what I mentioned earlier. It's just removal of some of the columns, some of the bits of data. This is focused just on the last 10 years, so it's just cutting off above and below and removing things like parts of data that are confidential, things that you can't really just throw around, and merging it with other pieces of data. Because as it comes out of the system, you get one large document, which is all the reports individually. I'll move back to the microphone. All the reports individually, and then you've got a list of authors for each record. There's a duplicate of the author. And what I did was flip it around, so there's just a little edge that contains, okay, this is one author here, and they've done all of these, and this is one author here, and they've done all of these. Just rotating the relationship of that around so it can easily flow through into the existing display. Which, as we were handed it, it's a wonderful system. Was inherited with a little bit of lack of documentation, but it's great. You take text of all the data I mentioned earlier as a sequence in the text file, reads it through, goes okay, traces the nodes out in a rendering, and then balances it out. As in, okay, these are too close together, we'll push them apart. These are too far away, we'll pull them together. As a node edge-based graph. That being what it is you've got a node, which is an author here, and along it are edges that are what they've collaborated on. So you've got, that's the core of it. And that goes for all the papers and all the interactions. Now, what I did was a fairly simple modification to it. Just instead of being the text file, I just put the SQL file in there, which just stores the data in a way that the interface part of it could then just make a request to. Could just say, hey, I would like to just focus in on this individual person, and go, you got it, chief? And hand it through, and none of the rest of the system had to change. It just accepted the new data as though it was the original system, just flowing through like that. Which produced this wonderful display right here. As mentioned earlier, node edge, and you've got things like the purple nodes are from science and engineering, maybe a little biased towards them. Health science, business has red, humanities is blue, business and law of green. The Curtin-related centres, like the centres of Aboriginal study elements and other centres connected to Curtin, are all grouped into orange. All other Curtin-related campus items, for instance, Curtin International or other Curtin elements that are not faculty or centres, are in a nice yellow. And for all other services linked to Curtin that can't easily be fall into any of these categories, go into the other. So those colours are put onto the nodes by faculty of this list here, and the records are the average of the colours, the lines connecting them. So if you can see, right, let me try and get right here, you can see a good example of that, where you've got a red and a blue joining together to make a purple. It's also pointing to there, for the last note of that, is it's isolated, a little isolated version around Talia Lever, I think that's what it says, and it's all focused on that person, so you want to, it's all the work that they've published across all the years in that section. Now, that isn't the standard view of it, because the data scale is still vast. It's been cut down to 35,000 and then confidential items removed, but it's still a vast data set. So for the usual view, as you can see over here, it is sliced into years, because it provides the context of when it was made and helps clear out any sort of the details. For instance, the environments that a paper made in 2014 is very different from something that was made in, for no reason in particular, 2020. So that it's something that needs to be reflected in how it's interacted with. And some other observations of the data is, while the most amount of connections or papers produced were from science and health related things, an interesting part of it is that the business, law, and humanities, while they didn't produce the most amount of papers as seen in the display, they did have the most amount of connections across faculty, which is quite an interesting thing. You can see, especially with things like health, they do rather often collaborate on those sorts of points. It's very interesting to see. Thank you for seeing it.